This is Mrs. Whitaker. I'm going to kind of start off differently. I'm going to start with a paper that we kind of used last year when we were teaching this, and to kind of review a little bit with this, and then we'll talk about the pages from your notebook. This one's a little bit more basic, so I think it might be helpful for some of you. Let's talk about the vocabulary from today. We talked about a constant term today. A constant term is it's a constant value. It's a number with no variable, so basically just a number. So if I had this example, 2x plus 3, the 3 would be the constant because it doesn't have a variable with it. What is a variable term? Is a mathematical term containing one or more variables. So a variable we talked about last week, which is a letter. So one or more letters. So in the above problem, and 2x plus 3, the variable term would be the 2x. And like terms are mathematical terms that have identical variables. So let me give you an example for this. If I did 2x plus 3x plus 3, well, I noticed that I have a 2x, x being the variable, and a 3x, another x as a variable. Those variables are identical. They're both x's, so I can put these two together. So it would now be 5x, and it would look something like this if I broke it down. It would be x plus x. That would represent the 2x, and then it would be plus x plus x plus x. So this would be the 2x's, and this would be the 3x's. And if I put all the x's together, I would get 5x. Please don't forget that this is multiplication because they're side by side. The 5x is multiplication. I'm multiplying the 5 times x. And don't forget that repeated addition is the same as multiplication. Okay, so we talked about some vocabulary. Here are some examples, and they did shapes, which I kind of did a little bit today in class when I taught the lesson. I would put the shapes together, so I know that 3x goes with the 6x, which if I put those together, it gives me the 9x. So 3x plus 6x would give me 9x. And then here, they put the squares. 7y plus 3y plus 4y. They all go together because they have the same variable, y. And if I put that together, I would get 14y. Then last, I would have 4z plus 2z. They're both z, so they can go together, which would give me 6z. So I went actually from 1, 2, 3, 4, 5, 6, 7 terms down to 1, 2, 3 terms by just combining my like terms. So here they asked me to simplify. Well, remember we also talked about if there's just a variable by itself, that's the same as saying 1y or 1x or 1z. So that's like 1y plus 1y plus 1y, which would give you 3y. This one would be 2x plus 1x plus 4x, which would give me 7x. Again, I'm able to put them together because they all share the same variable. 12, they all share y. 13, they all share x. Now if you look at 14, I have a 2z and a 3z. I can put those together, which would give me, 5z. They're both positive. And then I can put my 4y. He's all by himself. There's no other y's. So I would say 4y, and then my x is all by himself. So I would say 5x. So I went down from about 4 terms to 3 terms there. On 15, I have 1a plus 1a plus 1a, which gives me 3a, plus 1b and 1b, which gives me 2b. So basically, I just practice doing like terms and putting them together. So let's take a look at your prep work or your practice pages today. And this is kind of what we practiced together in class a little bit here. We talked about the number 3, and we wrote all the ways that we were supposed to make an addition expression, so I should not have included these. To get me 3, I could write these are all equivalent to 3. These are all equivalent to 3x. Again, we weren't supposed to do subtraction. Now, we talked about this one that you see right here. Why can I do x times x times x? Why can that not give me 3x? Well, because that's repeated multiplication. So repeated multiplication is when we have exponents, and repeated addition is when we have multiplication. So this is repeated addition, which goes with multiplication. This goes with exponents. If you look at C, again, I was supposed to keep it with addition, so I could have done that. I could have done 2x squared plus x squared. That would have also given me 3x squared. When we have exponents and we're multiplying, when we're multiplying, we're making repeated addition, the exponents just stay the same. Okay? So we practice a little bit with models today. We have these models in class, and they're called algebraic tiles. And so what you see right here is where I wrote it all out separately. Then you see here where I start to put my like terms, right here. I start putting my like terms together because I had 2x to the second powers. Now, mind you, we can't put the x with the little exponent 2 with the regular x's because they do not look the same. X to the second power is not the same as just x. So we cannot put those together. You can kind of see where we wrote some things out today. We kind of reviewed a little bit about what a coefficient is. The coefficient is always right beside the variable. So the coefficient in this problem would be 3. And they asked you, I think it says, what is the coefficient of x in the expression? It was just 3. Then we practiced some more in class. We did some more right here where we had to write it all out. Then we start putting our like variables together, and we got this. So we went obviously from like 9 terms to 2 terms. Then they gave us a problem, and we had to actually make the tiles. So if it said 3x to the second power, then I wrote out 3 of them. 1, 2, 3. It just looked like it had 1x, so I just wrote 1x, and it had the constant of 2. So how do I get 2? I do 1 and a 1. So you can see where we worked out some problems. Let's take a look at some examples from class on some of your other pages. Here are some examples with distributive property where we had to distribute out the 2 with everything in the parentheses. Now, when we're doing distributive property, I can put my unlike variables together. So if you notice, I have a 2 and an x. Since I'm multiplying them, I can put them together because that's like 2 times x, and I can create 2x. And then I can do 2 times 5, which gives me 10. Then I can do 4 times x, which gives me 4x. And then 4 times 7, which gives me 28. Now I have an algebraic expression with how many terms? I have 4 terms. I have 1, 2, 3, 4. Can I shorten it and put my like terms together? Yes, you can put your 2x and your 4x together. So now you have 6x, and you can put your constant 10 with your constant 28, which gives you 38. And now you went from 4 to 2 terms. So you can see some of my examples I did. Just kind of scroll down and take a look. Maybe you could pause it and try to do it on your own and see if you end up with the same answers as I did, and see if that helps. Our next page, now we're simplifying, And I know you have one kind of like this on your test, or on your prep work. Look at number 3. What they want you to do on number 3 is they want you to do the distributive property first because it involves parentheses. So I would do 3 times x, which gives me 3x, 3 times 1, which gives me 3, and then I still have that constant out there, plus 12. I don't multiply that 3 times that 12 because a 3 is only attached to whatever's inside the parentheses. Then I have 3 on the bottom, which means a fraction is like a division problem waiting to happen. So now I can divide 3 into 3x, which would just give me 1x, 3 into 3, which gives me just 1, and 3 into 12, which gives me 4. Now I look at my problem and say, is there any like terms I can put together? Yes, I have this constant and the other constant, and I can put those together. So now I have my x plus my 5 constant. So also look at number 5. This is one we had to talk about, where if we have a positive 3x and a negative 3x, they cancel each other out. So if I have 4x minus 4x, that would be like if I gave you $4 and then took $4 away, you would be left with nothing. You would be left with 0. They cancel each other out. Because you got to remember, the 4 is attached to the x. The x gets canceled out as well. If you look at number 6, this was an example where we had no fewer terms. I had no other x squares to put with him. I had no other just y's to put with him. I had no other x's to put with him and no other y squares to put with him. So it's just as low as it can go. So it's just going to be at 4 terms. So let's take a look at, this might be one of the problems I think you guys had, but we probably didn't get to it today. Looks like this. Hold on one second. Okay, so let's take a look at some of these. So if you look at the first one, I'm going to do my distributive property first. You're going to see me do this first. And I would do 4 times x, which gives me 4x, 5y, which gives me 20y. And then I would bring in the last part of my problem, minus 3x. Now I look at my whole problem and say, is there any like terms I can put together? Yes, I have a 4x and a negative 3x. So it's like I have 4 x's, and I take 3 of them away. So I take 1, 2, 3. What am I left with? Just 1x, which we write just as x. And then the plus 20y, because he stays, because there was no other y's to put together with him. If you look at number 10, I do 2 times 2x, which gives me the 4x, and then 2 times 5y, which gives me 10y. Then I do the same thing over here. 3 times x gives me 3x, and 3 times 3y gives me 9y. Now I say, is there any like terms I can put together? I can put only 4x with 3x, which gives me 7x, and then 10y plus 9y, which gives me 19y. And that's as low as I can make it. And then you can kind of see my other examples here. Again, you kind of see where I have a 3y and a negative 3y. So what happened to them? They canceled out, and I was just left with the 2x. Here are some more examples you can see that I did that you can look at. Maybe try them on your own and see how it goes and see if you get the right answers. On your homework tonight, you had to do, oops, I don't think I took a picture of it. Let me see if I can take a picture of it real quick. Which would be page 33. Hold on one second. Okay, here's your homework. And on your practice, first part says represent the algebraic expression by sketching tiles, and then rewrite the expression in fewer number of terms. So here, I just have an x squared. So if I was drawing the tiles, I would draw a box, and I would put x squared inside it. Then I would do another box, and I would put y squared. I would put another box and put y squared, and then I would put a 1, a 1, a 1, a 1, and a 1, because that gives me a total of 5. That's what the algebraic tiles would look like. Now, if I put my parts together, I have rewrite the expression in fewer number of terms possible. Well, they already wrote it in the fewest number of terms. You cannot make it any lower because I don't have another x squared to put with him, and I don't have another. They already put the two y squares together, and they already put all the single tiles together that are the constants. And so, but I do notice in B that there are going to be some you can put together. So again, they want to see the tiles, and then they want to see it written in the lowest fewer number of terms. Number 2, you're rewriting expression by combining the like terms. And B, the same thing. You did not have to do any of 3. Okay, you did have to do number 4. Rewrite each expression by applying the distributive property and then combining the like terms. We practiced this right before we got to the homework, where you would do 7 times 2x, which would give you 14x, and then 7 times y, which would give you 7y, plus, now you got to do 5 times x, which gives you 5x, and 5 times 4y, which gives you 20y. Now you got to start putting your parts together, your like terms. So I got 14x and 5x. That would give me 19x. And I can put my 7y with my 20y, which would give me 27y. So there's an example for A on number 4. You can do B and C. Number 5 says rewrite expression as a product of 2 factors so that the coefficient of the variable is 1. So what you're going to want to do here is you're going to want to figure out expression as a product of 2 factors so that the coefficient of the variable is 1. So you're going to want to, this one's going to be difficult. You're going to want to pull out the 6, which 6 does not go into 7. We're going to have to find a way to have that happen because we have to keep the x by itself. So I would do 6 times x to give me that 6x. Now, what can I put here that would give me a total of 7? Well, if I put 42, let me think about this for a minute. I have to multiply the 6 times something to give me 7. What if I put 7 over 6? Because if I work that out, 6 times, it would look like this. It would be 6 over 1 times 7 over 6. If I work that out, it would be 42 over 6, which would give me the 7. That was a hard one. So those of you that get to watch my video, you are going to get part A. I think part B is going to be tricky too. So now that you know what we did with A, hopefully you can solve it. But remember, you're going to have to get the x by itself. So you're going to pull out the 2/3 so that you're left with x plus. Now you're going to figure out this part. Whatever you have in there, it has to equal 8. Okay? So because remember, you multiply these two, it gave you 2/3 x. And then you're going to multiply this to give you 8. Okay? So your problem, you have to figure out what goes in that box. I'm not going to do the back side. The back side was stretch and then the review. On the review, you did not have to do number 1 on the review. but you must do number 2, which was determining a faster rate, which, remember, you might want to find out what 1 hour, how many miles it would take for 1 hour. So you're going to be doing unit rate to figure out the fastest rate, which unit, we talked about this the other day, is it's over 1. Or you have to maybe divide. Number 3, you have to find the volume, which is length times width times height. Now remember, you have to find maybe the volume of this part and then this part, and then you would add your 2 volumes together, whatever you get for each part. So you're going to add the volume of A with the volume you got for B to get a total. But this was just an example. This does not look like what your paper looks like. I hope this helps you. And again, let's review. Don't forget that if I put this down, this is the variable. This is the coefficient. Whoops, there we go. This is the variable. This is the coefficient, okay? And if we're talking about terms, don't forget that the terms are what go around the operation. So that means I have 2 terms here. And then if I have an exponent, don't forget this is the base. This is the exponent. The whole thing is called the power. Don't forget this is repeated addition. This is repeated multiplication. Repeated addition. This is repeated multiplication. Okay? So this would be x plus x plus x plus x. And this would be 7 times 7. So hopefully that helps you. Again, I expect everyone to have their homework tomorrow. Have a good night.